Good morning, students. Today I would like to explain the concept degree of freedom from the subject dynamics of machinery of final year. So, students, degrees of freedom means it is defined as the number of independent variables that must be specified to define completely the condition of system. It is also equal to the number of independent displacement that are possible. So students, there are two types of degrees of freedoms. Sorry, three types of degrees of freedom. First is single degrees of freedom. Students, single degrees of freedom means we'll show one diagram, which diagram shows first figure A shows the spring mass system. So in this case only here we show one spring mass and x displacement shown, that the diagram shows the mass supported on spring and constrained to move in one direction x only without rotation. So in single degree of freedom system, in this case only one independent coordinate, that is here is x, is required to specify the configurations. Next, move towards example figure number B and C. So figure number B shows 4-bar mechanism, figure number C shows slider crank mechanism. So in case of 4-bar mechanism and slider crank mechanism, the diagram shows for every value of theta there is only one value of phi, hence they have only one degree of freedom. Next, so next example is for pendulum, for simple pendulum oscillating in one plane. So next is the figure shows the torsional vibrations, that is figure D shows the simple pendulum. That figure explains the torsional vibration means the disc, here disc is attached, that disc is suspended at the end of the rod and twisted in torsional plane. Here twisting angle is theta, that shows the torsional vibrations. So these are the some examples of showing single degree of freedom system. Here we have only define the one value, that is theta, in case of single degree of freedom system. So students, next type is 2 degrees of freedom. So in 2 degrees of freedom there are two independent coordinates to specify the configuration. So first diagram shows, that is for two mass and two spring system. Here stiffness K1 and K2 are shown for springs, and M1 M2 are the masses, and X1 X2 are the displacement, means these are the two independent coordinates X1 and X2, means here there are 2 degrees of freedom. That diagram shows the two mass and two spring system constrained to move in one direction only without rotation has 2 degrees of freedom. So next example of 2 degree of freedom system is two spring mass system. Here diagram shows two springs and mass system, mass is attached. So diagram shows the mass supported on a spring which can move in the direction of spring and also have angular motion, that is theta, in one plane, has 2 degrees of freedom. Here 2 degrees of freedom are x and theta. Next diagram C shows the combined motion, here spring and oscillatory motion, that is spring and slider motion is attached to that combination system. which involves the linear motion of spring or slider and oscillatory motion of pendulum. Here pendulum is attached to the slider and which has the motion, that is due to which the angle theta is generated. That means that is nothing but here 2 degrees of freedom x and theta are to be occurred. Third type of degree of freedom is multiple degree of freedom. So diagram shows the body in space having 6 degrees of freedom. Multiple degree of freedom means, students, in this case there are multiple independent coordinates to specify the configurations. The diagram shows the body in space has 6 degrees of freedom, that is linear motion in direction x, y and z and angular motions about this axis. So here show 3 axes and 3 linear motions. Next, students, important is infinite degree of freedom. Next type is infinite degrees of freedom. Figure shows the flexible cantilever beam. In this case, the beam has infinite number of mass points, that shows in the diagram, which require infinite number of coordinates to specify the system. The system with finite number of degree of freedom is called as lump parameter or discrete system, whereas system with infinite number of degrees of freedom is called as distributed or continuous system. So student, this all is about degree of, what is meant by degree of freedom, types of degrees of freedom, that is first degree, 2 degree and multiple degree and infinite degree of freedom systems. So let us move towards next point, types of vibratory motions. So first type is free or natural vibrations. So what is meant by free or natural vibrations? If there is no external force on the body after giving an initial displacement, then the body is under free or natural vibration, is called as free or natural vibrations. The frequency of free vibrations or natural vibration is called as natural frequency. The examples of free or natural vibrations are oscillation of simple pendulum, motion of spring mass system. Second type of vibratory motion is force vibration. Students, force vibration means what? If the body vibrates under the influence of some external force F, then that body is said to be under force vibrations, and that vibrations are due to what? Due to the influence of or by application of some external force. Examples of force vibrations are vibrations in machines, IC engines, high speed turbines. Next type is damp vibrations. Students, damp vibration means if there is a reduction in amplitude of vibration after every cycle, then the body is under damp vibrations. For example, shock absorber of any vehicle, that is two-wheeler, four-wheeler, that is provided in the vehicle, is the example of damp vibrations. Fourth type is undamped vibration of vibratory motion. Students, what is meant by undamped vibration? If there is a no reduction in amplitude of vibration, or there is a no energy loss in friction, or there is having other resisting forces during vibrations, then it is known as undamped vibrations. For example, all physical systems possesses some amount of damping. So damp vibration and undamped vibration. The difference between damp and undamped vibration is that in case of damp vibrations, there is a reduction in amplitude of vibrations, but in case of undamped vibration, there is a no reduction in amplitude of vibrations. So these are the types of vibratory motions. So next point, student, is types of free vibrations. First type of free vibration is longitudinal vibrations. So diagram shows the particle of shaft or disc moves parallel to the shaft axis. Then the vibrations are called as longitudinal vibrations. Or the diagram shows that shaft is enlarged and shortened. That means here the diagram shows for shaft having some weight, that is mean position, and it vibrates under only a single plane, that is vertically vibrates, and that points are A dash and A. Means the diagram shows shaft is enlarged and shortened alternately. Hence here direct tensile and compressive stresses are induced in the shaft. Second type of free vibration is transverse vibrations. So students, transverse vibrations means what? If the particles of the shaft or disc move approximately perpendicular to the shaft axis, then the vibrations are called as transverse vibrations. For example, the diagram shows shaft and some weight is attached. There are two positions of shaft are given, that is A dash and A. Means shaft vibrates, means the particle of shaft or disc move perpendicularly, approximate perpendicular to the shaft axis. This is called as transverse vibration. So in this diagram shows the shaft is straight and bent alternately. Hence fatigue stresses or bending stresses are induced in the shaft. Next type is torsional vibrations. So the diagram shows some disc is attached to that rod having mean position, and that disc deflects at a distance A and A dash. So if the particle, the shaft or disc move in a circle about the shaft axis, then the vibrations are called as torsional vibrations. Diagram shows the torsional vibrations. So in this case, the shaft is twisted and untwisted alternately. Hence, torsional shear stresses are induced in the shaft. So these are the types of free vibrations, that is longitudinal vibration, transverse vibration, and torsional vibrations. And in general, some deflection of rod due to self weight is having equation delta is equal to capital W capital L upon AE, that is equal to mg, that is weight mg, into L upon AE. And we know that spring stiffness, that is K equal to capital W upon delta, that is W is load or weight upon delta is deflection. We know that W is nothing but mg upon delta, that is equal to mg upon delta is nothing but mgl upon AE, that is equal to AE by L. A is area, E is elastic property, and L is length in Newton meter. So this all is about from topics from the unit number 1 from the subject dynamics of machinery. Thank you, students.